Guten Morgen, meine Damen und Herren. Es tut mir leid, aber ich spreche nur einige Worte Deutsch. So I'm afraid I will be speaking in English. My apologies. It is always very embarrassing for me to come to Germany and you all speak beautiful English to me and all I can do is apologize in German. My name is Andrew Watson. I'm Technical Director of Object Management Group and I'm going to tell you a little bit about the modelling standards work that we do at OMG. Now OMG is, as an organisation is well over 20 years old, which means that that the teenagers who giggle about our name were not even born when the organisation was called OMG, which of course in English for those teenagers means, oh my God. If we had known that an entire generation of teenagers would use these initials to mean something else, then we would have called the organisation something else. But OMG it is. For the last 20, however many years, 24 years. So let me introduce us. We are an international, not-for-profit consortium of companies, both vendors and users of information technology, who work together to agree open integration standards for the computing industry. We are responsible for a number of specifications. Today I'm going to focus on modelling specifications such as BPMN and UML and maybe a couple of others that are not so familiar. But we also do other work. We do work in middleware layers, middleware software, to link separate independent subsystems together into larger systems of systems. Data distribution service, DDS, is an example of this. And we also have a number of vertical domain-specific groups that produce interoperability specifications in, for instance, healthcare, or government, or finance. That is a lot of our work, but I will say very little about that today, because today I'm going to focus on modelling. So we are, as I said, an industrial consortium. About half of our users are vendors of IT, and about half are users. So we have a balance between the two. We produce specifications that both the vendors are happy to implement in their tools, and also the users are happy to use. We only produce the specifications. We do not ourselves produce tools or software. But we do try to make sure that an implementation of each of our specifications is available, either commercially or as open source software, so that it can be used by an end user. Building a standard that is some magnificent, beautiful edifice built out of pure thought, but without tools that you can actually use, is not a lot of good to anybody. If we discover that one of our specifications is not being implemented and products are not available to users, then we will withdraw the specification. We are not interested in producing specifications for their own sake. We produce them so that we can create a market for the tools. Our work is free. Richard Stallman, at this point, always tells his audience that there are two meanings of the word free in English. I don't know if this works so much in German, but in English we use the word free both in the sense of free speech and free beer. Now, in the free beer sense, our specifications are free because you pay no money. You can go to our website and download them, PDF files. You don't pay anybody any money. But you also do not have to sign any license agreements. Our specifications are free in the sense of free speech. We do our best to make sure that if you want to use one of these specifications, you do not have to license patents or copyrights or other intellectual property in order to use them. I cannot guarantee that. Maybe there is somebody somewhere who has the master patent on some concept behind BPMN, and tomorrow he will emerge from his hut in the Siberian steppe, waving this patent and saying, "You all owe me because you are all using BPMN and I have this patent. I can't guarantee that such a person does not exist. But we have tried our best to make sure that the specifications are not encumbered by patents or other intellectual property that might prevent you using them. And we are a democratic organisation with our decisions taken by our members. This is not a complete list of our members, and if you know that your organisation belongs to OMG and you're looking at the slide and you're thinking, Andrew has left us off, then I apologise. You are one of the 200 more. This slide is just trying to show that we have a cross-section of both vendors and users. We have organisations from North America, but also Europe. About 50% of our membership is from Europe. And that we are, in general, we have a good balance between around the world and between technology areas. So we perhaps immodestly claim that we are the home of modelling standards. You are probably aware of UML, the Unified Modelling Language, and BPMN, and I will tell you a little bit more about these standards in the course of the talk. Some of these other acronyms may or may not be familiar to you. Again, I'll talk about some of them. UPDM is a visual notation for modelling the artifacts in DODAF and MODAF. These are enterprise architectures used by the US Department of Defence and the UK MOD, and now also by NATO. And although these enterprise architectures were originally designed by the military, in fact they are usable for all kinds of enterprises. UPDM is a visual notation for drawing visual representations of these artifacts, and it is an OMG specification. And right at the middle of this slide is a thing called MOF, the Meta Object Facility. When we create specifications in OMG, we try to ensure that as much as possible there is an architecture behind them. And in this case, MOF is the Meta Object Facility, the common way of creating modelling languages that is used to create all of these modelling languages. So although as an end user you may never be aware of MOF, the fact that it's there means that vendors can use common tooling to create these different modelling tools, and a number of things like the interchange format XMI can be shared between implementations of many different, apparently separate modelling tools. We have a very good relationship with the de jure standards organisations, and in particular with ISO, and several of our most important modelling specifications have been republished as ISO specifications. For some markets this is very important, particularly if you are selling to some governments and so on. They make a requirement of their procurement that where possible you must use official international standards. ISO, actually technically it's the Joint Technical Committee between ISO and IEC, has a process that they call PAS, Publicly Available Specification. And this allows them to take an external specification, such as one from OMG, and republish it, really rubber stamp it as an ISO standard. And so this has happened with UML twice now, both the original UML and UML2 as these ISO standards, and BPMN just recently, within the last few months, has now been republished as an ISO standard, and there are a few more as well. So you can either go to the OMG website and download these specifications for free, or you can go to the ISO website and pay 240 Swiss francs to download exactly the same document from ISO. Exactly the same document. We do not give ISO the sources. We send them the PDF. They publish exactly the same PDF. Every pixel is in the same place on the pages of both documents. And, you know, I smile, you laugh, but it is very important to make sure that there is no divergence, that UML 2.4.1 is exactly the same as ISO IEC 19505. So you can claim that you are using both. Our specifications can be used to cover a very large part of the Zachman framework. As I'm sure you're aware, Zachman's framework is used as a sort of a meta-enterprise architecture, a way of classifying and describing other enterprise architectures. And I'm not going to go into all of the details, but various OMG specifications that are well known, like BPMN and UML, and others perhaps that are less well known, some of which I will talk about today, between them cover a very large part of the Zachman framework. So it can be used for modeling almost all of the enterprise if you are doing enterprise architecture. Now, I am a standards person. I'm not sure how this happened. I didn't set out when I left university to spend a career in standards, but inevitably, as somebody who believes in standards, I get to stand in the pulpit and preach briefly the sermon on standards. Why are standards important? Because sometimes standards have a bad name. In some areas, people, particularly in software, some people say, oh, you don't want to standards. It's slow, it's boring, they don't do anything useful. Of course, this ignores the fact that so much of what we do in IT is built on standards. The VGA that connects my computer to the projector, eventually, successfully, is a sort of standard, an industry standard. The wireless standards, 802.11 that connect my laptop to the network, they're all standards. Standards help us integrate systems, but more than that, standards can create markets. And what happened with the UML specification is a great example of this. If you have a few grey hairs like me, or perhaps more, you may remember back into the early 1990s, there were basically no standards for drawing blueprints of software. There were half a dozen different techniques, each with their own little band of enthusiasts, you might say zealots. But because the market was split, no tool vendor could risk supporting any of these techniques with tooling because a large part of the market would be closed to it. In the mid-1990s, OMG created or helped, provided a forum for the creation of a single standard, UML. Now, we can criticize all sorts of aspects of UML. You know, as engineers, we can sit around the table and point to things about UML that are not very good and perhaps could be improved, and we're always seeking to improve. But the very fact that the standard existed, even though in some ways imperfect, created a market. And through the early 2000s, that market grew very rapidly. In around 2001, 2002, when at some large telephone companies, people were walking down the corridors, taking out every second light bulb to save money because of the IT recession, the market for UML tools was growing at 20% per year. And today, we have more than 70% of software developers, probably today more than 80%, using UML in some form, even if only to sketch on the back of a cigarette packet their ideas. They may not be using tools. There are dozens of tools, there are books, there's training, there's certification. Standards grow markets. Standards are standards drive innovation. And it's not a zero-sum game. If you create a standard, customers come into the market. This, I believe, is one of the things that UML demonstrates. So forgive me for preaching the sermon on standards, but standards, as I say, used appropriately, very important. You probably all know what UML is, but let me just very briefly say in one slide, UML is actually a family of 13 visual modeling notations. as I said earlier, all based on a common infrastructure for creating modeling notations. And it was originally designed to support object-oriented analysis and design of software. It has two broad classes of diagrams, those that represent static structure, like class diagrams, and those that represent dynamic behavior, like activity diagrams. And in fact, of these, all of these diagrams, class diagrams are the most widely used in software. So although there are 13 different diagram types in UML, almost everybody uses class diagrams, and at the other extreme, things like package diagrams are probably very little used. And as I'm sure you're aware, this is what a class diagram looks like. I'm not going to go into a lot of detail on this. But again, as a result of the standard existing and then the standardized tooling existing, UML is now being repurposed for a number of other domains. And here is an example, SysML. SysML is the systems modeling language. It is an extended subset of UML for specifying and designing complex systems which typically have components that are hardware, software, human components, perhaps fluid flows. An oil refinery is a good example of a complex system that can be designed and modeled using SysML. Or perhaps in a large car manufacturer, there would be just a few people who are responsible for designing the top-level system, the entire car, who would use SysML to help them represent, to model the entire car. A domain that's actually quite different from modeling software, but there are common features. Systems engineers started using UML, repurposing it for this, and seeing a need, OMG cooperated with INCOSE, the International Systems Engineering Organization, to create a standard which has some new diagram types, like requirements diagrams for modeling systems requirements, and modifies other UML diagram types. Because of the extension features that are built into UML, UML tool vendors, several UML tool vendors, are now also SysML tool vendors. They can take their UML tool and use the profiling mechanism to also support SysML with little extra work. So it's supported by multiple tool vendors and now has strong uptake in aerospace and defense industries and is starting to be seen in some other areas as well. And in common with some other modeling notations, not for every modeling notation, but for some of our work, OMG now also offers engineer certification. This is very important in some markets like Japan, and I think also in the DAC-speaking countries, it has a lot of traction, where if you are an expert in an area, it is useful to be able to go and get independent certification so that you can show your employer or your clients that yes, you are independently certified as being an expert in this area. And so in UML, SysML, and a number of other modeling languages, OMG provides certification. Not training. Training is done by commercial companies. Not even the testing. The testing for the certificate is done by Pearson VUE. But we work with experts to provide the independent certification exams. So SysML is an example of an area where UML, a standard for designing, originally for designing software, has been repurposed. Why does repurposing UML make sense? It's increasingly being used outside software development because, first of all, it turns out that class diagrams are actually usable for data modeling in many domains. In the Geographic Information Systems domain, the GIS domain, users of GIS tools often create data models using UML class diagrams to represent the structures that they model in the real world, the positions of lampposts and motorway flyovers and drains. There is ubiquitous tool support, and the notation is already, particularly the class notation, is already widely understood. Because of the well-understood and well-supported metadata infrastructure underneath UML and the extension mechanisms that are built into UML, it is relatively straightforward to repurpose a UML tool for other purposes. And indeed, there is now a growing list of other purposes for which UML is being repurposed. I mentioned briefly the unified profile for DODAF and MODAF, which we call UPDM. This is a UML-based notation for representing enterprise architecture artifacts from DODAF and MODAF. There are UML profiles for designing those irritating voice response systems that you get when you phone up your bank these days. Press 1 for this, press 2 for that. The trick is, of course, it's always press 0 to speak to a real person. That's what I always do. But nevertheless, maybe the person who designed that irritating voice response system used a UML profile to draw the path that they wanted you to take through the menus until you pressed 0. There is a UML testing profile for modeling the testing of software, the requirements for testing software. And inside the pure software domain, there are also UML profiles for particular deployment technologies, like particular middlewares, or particular design approaches, like services. So there is a profile called SOA ML for designing specifically for designing service-oriented architecture systems, or for modeling real-time and embedded systems with the particular constraints they have. So UML is so successful, oddly enough, precisely because it is not always used in a standard way, because it has the built-in capability to be repurposed for related and unrelated domains. And as I've said, UML and many of the other specifications, modeling specifications, are based on this meta-object facility. And you could use UML for an entire lifetime and never know this, or never have to care. But MOF provides the metadata foundation for all OMG modeling specs. It specifies the information modeling for storing information that underlies the diagrams. And because we have a rigorously specified foundation underneath UML, it is possible increasingly now to take the artifacts the diagrams that you have drawn, and extract information from the underlying model to produce some or all of the target application, the application that will solve the particular problem you are addressing. You can get hold of MOF tooling. eMOF, which is the OMG specification, is mostly aligned with the Eclipse modeling framework, eCore. So if you go to Eclipse, you can pull down free software in Java that implements parts of MOF. If you want to strike out on your own and build MOF tooling to process the underlying model that underlies your UML diagrams. And because there is a common underlying metadata format, we also have a standard for model interchange, which takes those underlying structures and serializes them as XML, and provides us with an exchange format, XMI, stands for XML metadata interchange. Most modeling tools that support UML provide some level of XMI export, but I would be the first to admit that the compliance to the standard of those tools has not always been the best. And 5 or 6 years ago, it was rather embarrassing for me to stand up at talks like this and talk about XMI, because actually the standard was so badly supported that if you exported XMI from one tool and tried to import it into a different tool, it really didn't work, and that missed the point. So about 6 years ago, we started a testing effort inside OMG, and a model interchange working group has been working continuously since then. They have achieved a number of milestones along the way. Certainly, as long ago as 2009, they were achieving 6-way tool interoperability between this list of tool vendors, and a couple of others have now joined. If any of you here are from a tool vendor and you would like to participate in this interoperability effort, in the interests of your customers and the adoption of the specification, we would love to speak to you, because I think it is very important that customers have the assurance that if they have created, invested potentially millions of euros in modeling their artifacts in one tool, that they can move their artifacts around to other tools. Not just so they can abandon your tool, but so they can use plugins and other tools that process those models and use them for new applications. More recently, we have some new additions to the UML family around executable UML. These two specifications, the executable UML foundation and the action language for FUML, provide a computationally complete subset of UML and a concrete syntax for writing, in a sense, programs in that subset. We also now have, and I won't say too much about this, but we also have a specification for modeling user interface behavior, which is something that UML was never very good at in the past. So between all of these specifications, we now have the ability for you to create models of the static structure in what you might call traditional UML, of the executable semantics of the program in FUML and ELF, and the user interface in IFML, and literally model the complete behavior of an executable application in a family of 3 or 4 different OMG specifications. And thus bringing the dream of completely model-driven execution, model-driven specification of applications, one step closer for many users. So I spent quite a long time talking about OMG's family of specifications for modeling software and some of the ways that they've been repurposed. Now I'll spend a few minutes talking about some of our business process and business modeling specifications. And these are all based around supporting business process management, which I say a kind of a new approach to business IT, maybe new a couple of years ago, but now increasingly recognized as an important tool in the armory of business in effectively using information technology. Again, as I'm sure you know, business process is defined as a sequence of activities performed by people and software, both people and software, in order to achieve one of an organization's goals or sub-goals. And business process management is a systematic approach to discovering, documenting, and continuously improving an organization's business processes. And all 3 of these are very important. Now, this graph, I think, tells a story that many of us know deep down, but it's worth reminding ourselves occasionally. The software industry as a whole has a disastrously bad record of delivering solutions to customers. These numbers are taken from Standish Group's Chaos Chronicles, and they cover the years from 1994 through to last year. And there is some debate about the exact figures, but nevertheless, everybody, I think, in the software industry would have to admit that there are some hugely expensive, hugely embarrassing software failures each year. I'm from the United Kingdom. I can point at several world-class software disasters in my government's IT procurement. We had a system, we had a program for procuring IT for our National Health Service, £4.7 billion flushed down the drain. What's that? 7 billion euros. 7,000 million euros. If hardware engineers, if people who built bridges did it as badly as we build software, then bridges falling down and buildings collapsing would be a daily occurrence. Now, occasionally bridges do collapse. And a few years ago, you remember part of Charles de Gaulle Terminal 2 collapsed. People die when that happens. It's a serious business. But it's very, very rare. Whereas in the software business, the equivalent of that kind of thing happens every day. And it's this, on this graph, here is the percentage each year of the projects, according to Standish, that succeed. And we've achieved the giddy heights of almost 40%. Here are the ones that just fail unambiguously, just deliver nothing for all the money that's spent on them. And according to Standish, we're down to only 18%, which historically, for our industry, is very good. And then there are the ones in the middle that sort of don't quite succeed, but don't completely fail. They deliver something, it just wasn't really quite what the customer wanted, or they cost way too much. It's pretty bad, isn't it? As I say, we can argue about the exact numbers, but the big picture is clear. Why does this happen? Well, there are a number of reasons, but for today, I just want to mention one, and that's because, of course, we believe we can help in this. Business process maturity model. Many of the IT catastrophes are the fault of the IT industry, no question. But some of them stem actually from the state of the organization into which you are trying to deliver a solution. Because if there are no stable, consistent requirements to be gathered, then you're not going to be able to gather them. And that means you're not going to be able to produce a requirements document that actually matches the customer's requirements, which means you're not going to be able to write an application that meets those requirements. Well, you will. You'll produce a requirement that meets some requirements. Sorry, an application that meets some requirements. And then you'll deliver it to the customer and they'll say, quite what we wanted. If a target organization's business processes are inconsistent, ad hoc, not repeatable, or deliver hard to predict results, then no amount of automation and computerization is really going to help them. And the first thing you need to do is identify these problem organizations and maybe help them actually have consistent, repeatable processes so that you can then automate those consistent, repeatable processes. How to do this? Well, there is no magic bullet, but a framework that may help is a specification called BPMN, Business Process Maturity Model. It is analogous to CMM, which I'm sure many of you know of. CMM is the capability maturity model, which is used to show, to document how repeatably and consistently an organization produces software to some set of requirements. BPMN is the analogous technique applied to the whole organization, aims to measure and help improve organizational readiness for technology deployment. So I don't want to say that these are the only set of problems that trigger software disasters, but it is a source of problems of software disasters. So BPMN provides, just like CMM, 5 levels from initial, which is chaos, where processes are performed in inconsistent ways, sometimes ad hoc, results difficult to predict, usually based on individual acts of corporate heroism by people sitting up all night or working weekends or whatever to deliver, make that deadline. And working through a managed level with local work groups at least behaving repeatably, even if different work groups do the same job in different ways, up through standardized and then predictable, to achieve business process nirvana, which is level 5, where an organization not only does things in a repeatable way, but is also can identify the gap between what it currently does and what its objectives are, so that you can then implement changes to address those gaps. So the first step in modeling what an organization does in order to help automate it is to make sure there is something to model. BPMN allows you, as a practitioner, to determine, is there anything here to model? If there isn't, I guess you have 2 choices. 1, walk away. Or 2, help that organisation improve and do things repeatedly, so there is then a repeatable process that you can then help automate. The next step is to identify what are the organisation's objectives and ends. And this sounds kind of obvious, maybe it is kind of obvious, but the business motivation model provides a very simple structure that allows you essentially to capture an organisation's business plan, really, its objectives, its ends, what it wants to achieve, and the means, how it will fulfil those ends. And also identify some of the influence and assessments and so on, which then provides us with a framework within which we can model individual processes to achieve those outcomes. And again, BMM is an OMG specification. And then once we've done those two things, first of all, made sure there are processes to model, and secondly, worked out what the organisation's goals and mechanisms are, then we can use the specification that I hope many of you have heard of, which is BPMN, Business Process Model and Notation, to capture those processes as a precursor to helping to automate them. And certainly I know that MID and, of course, other tool vendors as well today have very strong support for Business Process Model and Notation, BPMN. But I wanted to emphasise that you don't start here. You start 3 slides ago. Are there processes, and what are the objectives? And then BPMN, as I'm sure you know, provides a syntax for capturing those processes. And it's certainly the most widely used process notation standard. This survey 3 years ago by BP Trends said that probably 50% of people who are modelling business processes are using BPMN. What are some of the others here? You probably can't read the key here. Some of them don't really look like business process modelling notations or business process modelling techniques to me at all. I mean, OMG's model-driven architecture, work that we do, is on the chart there. I think those 5% of people were confused. But, nonetheless, happily, say 50% BPMN. UML, incidentally, UML notation, 7, is also surprisingly widely used for modelling business processes. And that's not, that's perhaps slightly surprising. The difference between BPMN and UML activity modelling, for instance, is not in what they can model. Their semantics are about the same. It's really that BPMN tools are built to automate enterprises, and UML tools are built to help you write software. So the difference between them is not in the capabilities of the language, it's in what the underlying tools are built to do. So the people who are using UML for this are probably, they're using the tool to draw the diagrams, but they're not necessarily getting something useful out of the machine-readable part of the model to help them actually automate their enterprise. I'm sure everybody in this room knows what, does anybody not know what BPMN diagrams look like? This is a very, very simple example of a BPMN diagram that you could fit on a t-shirt just to illustrate the basics of the notation, but I won't talk about it if everybody's familiar with BPMN. So just a little history. BPMN was published initially by an organisation called BPMI in the mid-2000s. That organisation merged into our organisation, OMG, in June 2005, and we published BPMN 1, and then produced around the beginning of this decade a second version, BPMN 2, building on the experience of BPMN 1, preserving the syntax, introducing a formal meta model, and again, as I say, providing something that we can send to ISO. And again, with BPMN, just as with UML, a few years later, we have started working on ensuring that there is interoperability between the tools so that you can pull models out of one tool to process them or to import them into a different tool. And these tool vendors, 7 separate tools from these tool vendors, were demonstrated interoperating in Berlin back in June. And again, if anybody else is interested in participating in interoperability testing at OMG, of UML tools, sorry, of BPMN tools, then do please let me know. And as with our other modeling specifications, although our job is to publish the specification, we also think it's very important to build an ecosystem, because an ecosystem around a specification is a symptom of and a driver for its success. So the foundation is the specification itself, and of course the implementations from tool vendors like MID, but it's also important that we have books, training, certification, and again there is OMG independent engineer certification available to become an OMG certified expert in BPMN. Conferences, perhaps like this one, a small part of this conference is devoted to BPMN, discussion fora, and so on. So BPMN today has an entire ecosystem, and I spent a happy half hour with Amazon a couple of years ago just pulling the book covers off so that I could put up slide after slide of book covers of all of the materials that are available. You know, this is a symptom of a healthy ecosystem around the specification. And as I've touched on a couple of times now, certification, engineer certification, such as OMG's BPMN certification. So I have just 3 minutes left, so I'm going to tell you about a couple of other business modeling related specifications that may not be so familiar. SBVR, Semantics of Business Vocabulary and Rules, is again based on our common MOF meta model, and it provides a formal, precise, unambiguous, but easy to understand syntax for defining business rules. It has two different syntaxes, a structured English syntax and a rule speak syntax, both based on English, unfortunately. I don't know if there are syntaxes for other languages. There are no standard syntaxes for other languages. And it's a good way of representing policies and other requirements. SBVR allows you to define two kinds of rules. One is definitions, dictionary definitions of the vocabulary used in a business, defining complex terms in terms of simpler terms. So here is a single example from the specification, which has a large complex example of rules for a car hire organization. A customer has at least one of the following: a reservation, an in-progress car hire, or car hire completed within the 5 years. And in this organization, this is the definition of customer. As I'm sure you know, sometimes in organizations, when there are problems with building software to automate the organizations, one of the problems is just a lack of agreement on what the terms mean. The second kind of rule are the operative rules, which are requirements governing the conduct of the activities that individuals in the organization must implement. A customer who appears drunk must not be given possession of a hire car, for instance. So SBVR provides a syntax, albeit a slightly unnatural one, but it's good enough that SBVR terms can be read with no training by a native speaker of the language. It is obligatory that each rental car is owned by exactly one branch. This is an SBVR statement that has a precise representation in the underlying model and can be checked by a rule checker against the entire vocabulary of rules to make sure that all of the definitions in the organization are internally consistent and can then be used as an underlying vocabulary for the terms in the organization. We have a number of other BPMN related standards, a case management model and notation based on BPMN2 to model case management. Case management is the way in which people like insurance companies organize their files of data about their customers and the ongoing relationship with them. An insurance claim, for instance, in an insurance company is usually handled in a way that can be modeled by the case management notation. And a date time vocabulary, and very recently a decision model and notation spec for modeling decision tables. So, my summary. OMG has a name that teenagers giggle about, but we develop and maintain the visual modeling standards on which the software industry depends. UML for modeling software artifacts, BPMN for modeling business processes, a family of UML profiles for modeling specialized software systems and also other engineering systems outside software, specifications for modeling user interfaces, SPVR for modeling business rules, and others. All of these are built on a common meta-object framework, which allows us, if we use two different languages for modeling different parts of our organization, to relate the models to each other and to extract information from them and use them for other purposes using common tooling. And we are focused on having, and I'm happy to say we do have, strong commercial and open source tools that support that, our ecosystem of specifications, and also OMG regulated engineer certification. If you would like more information about OMG and our specifications, please visit our webpage. There's a page about certification here. If you find a bug in one of our specifications, and I know there are plenty, because anything that's worth doing, there are going to be errors, and if you find one, please do report it via our bug reporting page here. And I've run all the way to the end of my time, and I apologize, but if there are any questions that you have that I could answer later by email, then please do email me. And also I have a stand out there in the display area, so do please come and ask me any questions you have. I'll be there until about 3 p.m. So thank you very much indeed for your attention, and my apologies for 3 minutes.